Ahead and review for the NeSA. Again, this is going to be day 4. This won't take a long time for us to get through at least today's lesson. And so first of all, let's go ahead and look up here on the board. What we're going to do is we're going to look at a table. And if you notice this table, it says school population by gender. And it's got males and females, and it's got the total in each of the classes. And then it's got freshmen, sophomores, juniors, and seniors. And so real quick, you notice that the 100 refers to both males and females together. There are 100 males and females, 50 of each. And then there are 100 total students, freshmen through seniors. So what is the probability of randomly selecting a student who is a sophomore?
24 out of 100.
So sophomore is 24, right? And so I am going to pick 24 out of 100. And so I do need to reduce that down. So what number goes into both? 4. So 4 goes into 24, and then 25. So this is the thing. They might reduce them down, they might not. You need to make sure that you know both. Okay?
I don't think it did on the test we took.
I don't think you had them reduced down either. So that's why you need to make sure that you can look for both. So let's look at the next one. What is the probability of randomly selecting a student who is either male or a senior? Okay, now this one you have to be careful, because how many males do I have? 50. Now the males include everybody right here. Okay, now they said, or you could pick somebody who's a senior. So how many more does that add in?
13.
13. Okay, so really if I have my 50 and my 13, how many are there?
63.
63 out of 100. Okay. So you kind of have to read and make sure that you're answering the question there. Find the mean of the set of data. What does mean that you find? The average. Okay, so the average here, I have in the interval 1 to 5, 6 to 10, 11 to 15, 16 to 20, and 21 to 25, 26 to 30. So the question is, what number do I use? You'll always use the number in the middle. It's actually called the class mark. So what would the number in the middle of 1 to 5 be? 3. What about 6 to 10? 8.
18.
So those are the numbers you're going to use when you have an interval. You always pick that number in the middle. If you wonder how to get it, you take first plus last and divide by 2. So 1 plus 5 divided by 2 gives me 3. And so really, to find the mean of the set of data, I'm going to take 3 times 5, and I get 15. I'm now going to take 8 times 4, and I get 32. I'm going to take 13 times 3 and get 39. 18 times 1, 23 times 2,
26.
and 28 times 1. 28. So to find the mean, that's the average, what am I going to do?
Add them all together and divide.
Add them all these up. Okay, so I'm going to add all those up together, and then I'm going to divide by the total number. The total number will be here with the frequency. So let's add these up. 5 and 2 is,
7,
and 9 is
13, 16,
16.
24, 30, 38.
So I've got 38 here, 3 and 1.
4, 7, 10, 11, 15, 16.
Okay, so the frequency is going to be how many times they occur. So 5 and 4 is, so basically to find the mean, I'm going to take 178 and divide it by 16. Okay, so you might have to reduce down if you could. 4, I think 4 doesn't go into 178, so you would probably have to do this and go from there. Okay? Or you could just see they might have that as your answer too. What?
Can you go by 2s?
You could go by 2. Well, if you go by 2s, it would be 89 over 8. And then you would have, yeah, divide. That'd work too. Okay? So then now let's think about this. This is one of those questions that makes you think. What effect would dropping the 2 scores in the 1 to 5 interval have on the mean? So when they say dropping 2 scores, let's say we would get rid of 2 of these. So really there'd only be 3. So what's that going to do to the average? Is it going to cause the average to go up or to go down? Why would it cause it to go up?
Because it's lower.
Because it's the lowest number.
Because you're dropping the lower numbers, right? When you drop lower numbers, it's going to cause it to rise. If you drop higher numbers, it's going to cause it to go.
If you drop the middle number.
If you drop the middle number, it's not going to have any effect. So let's look at this one. If you were to drop the same 5 scores, what's that going to do to the standard deviation? This standard deviation is like how much something varies from the mean. Okay? And so with standard deviation, you see a lot of that with the bell curve. Okay, like here's your average, and then the standard deviation is how much something goes to the left and to the right. Okay? So let's think about that. If I take out 5 scores on the bottom, that's going to mean that my set of data is more compressed, correct? So what's that going to do to the standard deviation? Is it going to make the standard deviation bigger, or is it going to make it smaller?
Smaller.
It's going to make it smaller. So what's it going to do? It's going to kind of compress it or make the standard deviation smaller. Okay. All right, let's look at this one. What is the probability of spinning both spinners, adding the numbers together, and getting a sum of 2?
0.
Sure.
Why can't you have that?
The smallest number is a 2.
Smallest number is a 2. The smallest sum you can get would be a 7. So what is the probability of spinning both spinners, adding the numbers together, and getting a sum of 9? So now we need to think. 2 and what will give me a 9? 7. So what's the probability of a 2? 1/4. What's the probability of a 7? 1/3. So you multiply those 2 numbers together. That's your first probability. Then what happens if you do a 3? A 3 with what will give you a 9? 6. So the probability of a 3 is 1/4. What's the probability of a 6? 1/3. Now we got to do a 4. 4 with a 5. Probability is going to be 1/4, 1/3. And so what you're going to do is add those up together. What is 1/4 times 1/3? 1/12. What is, here I get 1/12. Here I get 1/12. So you add them all together and you get 3/12, which would also be 1/4. So once again, with it being multiple choice, you would look to see if either 3/12 or 1/4 is there. Questions? Final thing. An item sells for $5 per meter. What is the cost in cents per millimeter for this item? Okay. $5 per meter. Now in this one, I don't think you have to do the multiplication out. I think they just have a bunch of things where you would say these all multiply together. So that's what we're going to do. $5 per meter. Okay, per, remember, means times. So let's start by converting meters to millimeters. So if I want to convert meters to millimeters, and if you use your cheat sheet, your reference sheet, that pink and blue one I gave you, they have conversions for you on there. And if you notice, they tell you there's a conversion. Isn't there a conversion between millimeters and meters? What do they tell you?
There's 10 millimeters per centimeter and there's 100 centimeters per meter.
Okay, so they tell you there's 10. So really, they tell you this, don't they? That in 1 meter there's 100 centimeters. And then they tell you that in centimeters there's, in 1 centimeter there's 10 millimeters. Isn't that what they tell you? And you might know that there's already 1 in 1,000. So these will cancel. We've done these before. And then now you need to convert dollars to cents. Okay? So if I want to convert dollars to cents, what can you tell me? $1 there is 100 cents. Okay, so let's look at the top. On the top, I have 5 and 100. So really, I have 500. What do you have on the bottom? 1,000. So it'd be 500 cents per millimeter, which would be basically a half of a cent per millimeter. So you're going to have to do conversions as well. All right, any questions? All right, I'll go ahead and hand out the worksheet number 4. Okay, and that will be due tomorrow along with 2 and 3.